Okay, so you're probably wondering, where were we going with this? Why did we do this this factoring? Why did we figure out that there was a hole at x equals 3? Well, the question is, can we fix the hole? We want to make a new function that does not have a hole. We want to turn this into what is called a continuous extension. In order to create this continuous extension, we need to fill the hole. So we're going to make a new function, g of x equals, well, it equals f of x, except when x is 3. Because when x is 3, this isn't defined. The question is, what's this y value? Let me put in red here, what is this y value? What is f of 3? And what I can do is I can take this part of the function and I can plug in x equals 3. So let's do that. On the bottom, I'm going to have 6. On the top, 3 squared, 9, plus 3 times 3 is 9, plus 2 is 20, which simplifies to 10 thirds when x equals 3. And I've now made this a continuous function by defining the piecewise function as it is f of x everywhere except right there at the hole, and I'll make it equal to 10 thirds right there because I need a continuous function for something. Okay, so there you go on that. Let's take a look at algebraic combinations of continuous functions. Guys, it turns out when you combine continuous functions, they make more continuous functions. So if you jump to page 82 in your book, you'll see that you've got one for sums. You've got one for differences. I don't know why I used the Greek letter for sums because there's no Greek letter for differences that I can remember. You've got ones for products, constant multiples, and quotients. Okay, constant multiples and quotients. If you take two continuous functions and you add them, subtract them, multiply them, divide them, or multiply them by a constant, you still get a continuous function. Obviously, with the caveat that the denominator is not 0 at that point. Okay? Composite functions. Guys, let's talk very quickly. I don't know how much time I have left on this video, but let's talk about composite or composite functions. I tend to say those words interchangeably at different times. G of f of x. Notice that f of x is the input into g of x. Hopefully you guys are comfortable with those. I don't know why that square just showed up. Another way to write this is g of f. Similarly, f of g of x can be written as f of g. So you're going to see both of these. The O means just do a composite function. And if you do a composite function of or more than one continuous function, your new function will be continuous within the domain of both of the functions. Okay? I'm going to go ahead and do an example of this, but that'll have to be on the next video because we're running out of time here. So I'm going to stop this video and we'll start the new one.